Hey there, welcome to Tech World GBA, your go-to channel for all things tech. If you love staying updated with the latest in technology, gadgets and tutorials, you're in the right place.
The Internet is a global network of interconnected computers and servers that communicate using standardized protocols to share data, resources, and services. It acts as the backbone for data exchange, enabling various forms of digital communication, from simple browsing to complex cloud computing. Here's a comprehensive explanation of how the Internet is generated, structured, and maintained from its origin.
The origin of the Internet dates back to the late 1960s, when the US Department of Defense's Advanced Research Projects Agency, or ARPA, developed ARPANET, which stands for Advanced Research Projects Agency Network. ARPANET was the first network to use packet switching, which breaks down data into packets, sends them through various routes, and reassembles them at the destination. In 1969, ARPANET's first successful communication occurred between computers at UCLA and Stanford Research Institute. By 1971, the first email was sent over ARPANET. Then, in 1973, the network went international, connecting to nodes in Europe. Finally, in 1983, the Transmission Control Protocol Internet Protocol, or TCP/IP, became the standard protocol for ARPANET, marking the true beginning of the Internet as we know it.
The Internet itself is not something that is generated in a traditional sense, but rather constructed, maintained, and continuously expanded through the coordination of physical infrastructure, communication protocols, service providers, and governing bodies.
The physical infrastructure of the Internet. It's pretty fascinating. First up, we have data centers and servers. The Internet relies on vast networks of servers located in data centers around the world. These servers store and transmit data such as websites, applications, and cloud services. Next, we have cables and fiber optics. The core of the Internet is built upon thousands of miles of fiber optic cables that transmit data at the speed of light. These cables run both underground and underwater, known as submarine cables, to connect continents. Now let's talk about routers and switches. Routers direct data packets between networks by determining the most efficient path, while switches manage data traffic within the same network. And finally, we have Internet Exchange Points, IXPs. IXPs are physical locations where different Internet service providers, or ISPs, connect and exchange traffic. These points are critical for reducing latency and improving data flow between networks.
Moving on to protocols and data transmission. The Internet Protocol Suite, known as TCP/IP, underpins all Internet communication. Transmission Control Protocol, TCP, breaks down data into packets and ensures reliable delivery by managing packet loss, while Internet Protocol, IP, handles the addressing and routing of packets to their destination. When it comes to packets, data transmitted over the Internet is broken down into small packets. Each packet contains a header with the source and destination addresses and the payload, which is the actual data. Routing is another crucial aspect. Routers use algorithms and routing tables to decide the path each packet takes. If one route is congested or fails, packets can be redirected through alternative paths, ensuring data delivery.
Now let's dive into ISPs and connectivity. Internet service providers, ISPs, are companies that provide internet access to homes and businesses. They connect users to the larger internet infrastructure through a variety of means, such as fiber, DSL cable, or satellite. The ISP ecosystem has a tiered structure. Tier 1 ISPs are the backbone providers that own and manage the primary infrastructure, including international cables and large-scale routing facilities. Then we have Tier 2 ISPs. These regional providers buy bandwidth from Tier 1 providers and distribute it to smaller networks or other ISPs. And lastly, Tier 3 ISPs are local providers that connect end users to the Internet.
The domain name system, or DNS, is a critical component of the Internet that translates human-readable domain names, like www.example.com, into IP addresses that computers use to identify each other. DNS servers maintain a directory of domain names and their associated IP addresses, facilitating the process of connecting users to websites.
Governance and standards. Internet governance bodies include the Internet Engineering Task Force, or IETF, which develops and promotes voluntary Internet standards, particularly TCP/IP. The Internet Corporation for Assigned Names and Numbers, or ICANN, manages domain names and IP address allocation. The World Wide Web Consortium, or W3C, develops standards for the web to ensure compatibility and accessibility. Protocols and standards such as HTTP and HTTPS for web traffic, FTP for file transfers, and SMTP for email communication ensure that data is handled consistently across the Internet.
The process of data transmission on the Internet is quite fascinating. When a user accesses a website, their device sends a request to a server using HTTP or HTTPS over TCP/IP. This is known as request initiation. The request is then split into packets and routed through various nodes, including routers and switches, to reach the destination server. This step is called routing. The server processes the request, retrieves the necessary data, and sends it back in packets following the same process. Finally, the user's device reassembles the packets in the correct order to display the content.
Moving on to challenges and innovations. The growing number of connected devices and data traffic increases the demand for higher bandwidth, leading to congestion issues in some areas. Security is another major concern, as the Internet faces constant threats such as hacking, DDoS attacks, and data breaches. Technologies like encryption and firewalls help mitigate these risks. On the innovation front, Content Delivery Networks, or CDNs, distribute data across multiple data centers to reduce latency and improve access speed. With the exhaustion of IPv4 addresses, IPv6 is being implemented to provide a vastly larger address space. High-speed cellular technologies like 5G and beyond enhance Internet accessibility, especially for mobile devices and remote areas.
To summarize, the Internet is a vast, complex network that originated from ARPANET and evolved through advances in technology and standardization. It operates on the principles of data packet switching, interconnected global infrastructure, and a suite of communication protocols. This extensive system relies on physical components like servers, cables, and routers, as well as services provided by ISPs and regulated by global standards organizations to facilitate seamless data exchange and connectivity worldwide.
Don't forget to subscribe to the channel and hit the notification bell so you never miss out on any of our informative videos. And if you enjoyed this video, make sure to like, share, and leave a comment below. We'd love to hear from you.